Hello everyone. So hope you all are doing good. Before starting today's video, let me tell you that you can find all the solutions in the Telegram group. You will get the link in the description and also I will comment it down. So do join it to get the solutions in C++ as well as in Java. So let's start today's video. Today's GFG POTD is about party of couples. So let's read the problem once. You are given an integer array of size n representing n number of people in a party. Each person is denoted by an integer. Couples are represented by the same number, that is, two people have the same integer value. It means they are couple. Okay, we need to find out only single person in the party of couples. We need to note one thing, that it is guaranteed that there exists only one single person in the party. So we are given up with two conditions, that is, couples are represented by the same number, that is, two people have the same integer value, and it is guaranteed that there exists only one single person in the party. So let's start solving this particular problem. So to solve this question, we will use a bitwise operator, that is XOR. Now why we are going to use XOR and what does XOR do? So if we XOR a number with itself, the result will be 0, and if we XOR a number with 0, then the result will be the number itself. So if we apply XOR in this array, then what we will get? It will cancel out the same integer value and then we will get the only single person. So keeping all these things in mind, so let's try to find out the XOR of this. So as I've told you earlier, that XOR of a number by itself will always result in 0, right? So let's try to find out how this is happening. So what is the binary value of 3? It is 0, 1, 1 and again 0, 1, 1. Now we need to find out the XOR of 3, XOR 3. So if the bits are same, then we will get a value 0. See, if the bits are same, then we are getting 0. And if the bits are different, then we are getting 1. This is the XOR. Okay. So similarly, let's apply here 1 XOR 1. It's same, so we will get 0. 1 XOR 1, again same, so we will get a 0. 0 XOR 0, same, so we will get 0. So the result will be 0. Now, what is 5 XOR 3? So the binary form of 5 is what? If you find the binary form of 5, then you will get 1, 0, 1, and for 3, it is 0, 1, 1. So these two are same, 1, 1 same, so it will give us 0. 0 and 1, see, they are different, so what are we going to get? It will give us 1. Again, it is different, so what you will get? A 1, because they are different, the bits are different. So you will get, if you convert this into decimal, you will get 6. So the XOR value will be 6. Okay, now let's start implementing. Let's try to solve this now. We will traverse the array and we will find the XOR value of each element. Okay, so what is 1 XOR 2? 1 XOR 2 is 0, 0, 1, and the binary form of 2 is 0, 1, 0. So the bits are different. What you will get? You will get a 1. Again, bits are different. You will get a 1. So what is this? 1 XOR 2 is 3. If you convert this into decimal, you will get a value 3. Okay, so now 3 XOR 3. See, the numbers are same. So we will definitely get a 0. So 0. Remember one thing, that XOR, if we do XOR a number with itself, the result will be 0. So we are getting here a 0. And if we XOR a number with 0, then we will get the number itself. Suppose if we XOR with 0 XOR 3, then you will get a number, that number itself. Okay, so let's proceed with this array. So 3 XOR 3, 1 is done, 2 is done, 3 is done. Now 0 XOR 2. So what is 0 XOR 2? As I've said earlier, if we XOR a number with 0, here we are doing XOR with 0. So what we will get? We will get the number itself. So 2. Again, now 2 XOR 1. 2 XOR 1. So what is the binary form of 2? It is 1 0. And what is the binary form of 1? It is 0 1. Different. So 1. Again, the bits are different. So 1. What is this? It is 3. So 3. And at last we will return this. So this is the output. See, here we are getting the output. Similarly, let's proceed similarly with this array. What is 1 XOR 3? 1 done, 2 is done. Now we will do 3. So 3 XOR 3. If we we XOR a number with the number itself, then we will get a 0. So 0. Now 0 XOR 5. What is 0 XOR 5? If we XOR a number with 0, then we will get the number itself. So we will get 5. Now 5 XOR 3. What is 5 XOR 3? We have calculated it earlier. See, we have calculated it earlier, the XOR value. So 5 XOR 3 is 6. Again, what is 6 XOR 2? Okay, so let's calculate. So the binary form of 6 is 1 1 0 and 2 is 1 0 0. Bits are same, so we will get a 0. Again, bits are same, we will get a 0. Bits are different. Bits are different, so we will get a 1. What is this? It is 4. If you convert this to decimal, you will get 4. So 4 XOR 1. What is 4 XOR 1? Let's find it out. 1 0 4 is, and 1 is 0 0 1. 0 1 bits are different. 1 0 0 bits are same. Return 0 1 0 bits are different. Return 1. So what is this? It is 5. Now 5 XOR 4. Again 5 XOR 4. 1 0 0. Bits are different. 1 bits are same. 0 bits are same. That is 1 1 0. It is 1. So return 1. Now 1 XOR 5. Done. Okay, 1 XOR 5. What is 1 XOR 5? 5 is 1 0 1 and 1 is 0 0 1. So bits are same. It will give 0. Bits are again same. Again 0. Bits are different. It is 1. So what is 1 XOR 5? It is 4. If you convert this, you will get a 4. Again, now we will do 4 XOR 6. Okay. So what is 4 XOR 6? 1 0 0 and 6 is 1 1 0. See, bits are same, so 0. Bits are different, so it will give 1. Bits are same, 0. So it is 2. Now 2 XOR 6. See, 6 XOR 2 and 2 XOR 6 is same. So here we have already calculated. So 2 XOR 6 is 4. Now we have got our answer. See, the output is same. So this is the answer. We will return 4 at the end. Now let's implement the code. So let's take our first element. We will start the iteration from the second element. Now ans XOR ri. Did XOR return the answer. Let's compile and run. We are getting correct output. Let's submit. Okay, so the problem solved successfully. So let's end the video here only. So please do subscribe and hit that like button to get more such content. Share your thoughts below in the comment section. Thank you for watching.